#YouTube script, robots that learn from almost nothing. **** duration **** ~2-3 minutes, ~600 words. Opening, hook. What if a robot could learn to drive without ever watching a human drive? Or learn to manipulate scissors from a single video? This week, a wave of robotics papers suggests that the data bottleneck is finally breaking. Visual, montage, a car driving autonomously, a robotic hand turning a screwdriver, a phone running an AI agent. Here are 3 stories about robots learning to do more with less. Story 1, TerraZero, driving from scratch. Let's start with the most technically impressive paper of the week, TerraZero. Visual, split screen, left side shows a simulated driving environment with randomized traffic, right side shows a car navigating a real city. TerraZero is a procedural driving simulator that trains fully learned driving policies with 0 human demonstrations. 0. No logged driving data. No fallback planner. Just simulation, randomization, and reinforcement learning. The key insight is simple but powerful: make simulation fast enough, 1.3 million agent steps per second on a single GPU, and diverse enough that every episode is different. The policy learns to drive not by imitating humans, but by discovering driving through trial and error. And it works. TerraZero is the first fully learned policy to top the InterPlan long-tail driving benchmark, ahead of larger learned planners. On routine driving benchmarks, it's the safest, best collision and time-to-collision scores. And it generalizes zero-shot across cities, even learning left-hand traffic without being told. Story 2, REGRIND, Dexterous Manipulation from a Single Demo. If TerraZero is about scale, REGRIND is about efficiency. Visual, a robotic hand picking up scissors and opening them, with a diagram showing the retargeting pipeline. Dexterous manipulation has been one of the hardest problems in robotics. Contact-rich tasks like operating scissors or turning a screwdriver are notoriously difficult to simulate accurately. And sim-to-real transfer has been a persistent challenge. REGRIND solves this with an elegant pipeline: retarget a single human demonstration to a robot reference that preserves spatial and contact relationships, train a residual RL policy in simulation to track object-centric keypoints, and transfer the resulting policy zero-shot to hardware. The result? Fluid, human-like behavior on 2 different multi-fingered hands across contact-rich tasks. From a single video. Story 3, the Embodied AI Roadmap. Visual, a diagram showing the path from simulation to real-world robots, with icons for driving, manipulation, and mobile agents. 2 papers this week offer a broader vision. From World Action Models to Embodied Brains lays out a roadmap for open-world physical intelligence, systems that understand physics, plan actions, and execute them in the real world. Xiaomi's U0 framework presents a unified embodied synthesis approach with a world foundation model. And PalmClaw brings agents to mobile devices, an open-source framework that runs natively on phones, managing sessions, memory, skills, and tools directly on device. It achieved an 11.5% improvement in task success and a 94.9% reduction in completion time. Closing? So here's the common thread: the data and compute requirements for capable robotic systems are dropping dramatically. TerraZero shows you can train a state-of-the-art driving policy from scratch with no human data. REGRIND shows you can learn dexterous manipulation from a single video. PalmClaw shows you can run capable agents on a phone. The bottleneck in robotics is shifting from data collection to simulation quality and algorithm design. The field is learning to do more with less, and that changes everything. Visual, text on screen, robots that learn from almost nothing with paper references. This story covers 6 papers on robotics and embodied AI from R14, July 10 to 15, 2026. Full references at monizessaresearch.com.